Right, so if the beta, say your estimated beta is maybe 0.5, so what they do is they weight the actual data with 2/3, and then the one, they weight that with 1/3, right? So that would be 2/3 times the half, that's 1/3 plus 1/3, so instead of 0.5, they use 2/3 as the beta, right? So they increase the beta towards 1. Now the opposite thing, if this beta here, the raw beta is above 1, then averaging it with 1 would actually reduce the beta, right? So they shrink the beta towards 1 from any direction. And maybe let's first look at what the economic rationale behind this is. If you look at this picture, we found out that the empirical security market line was too flat, right? So suppose you're here, and that's your actually raw beta, right? So you know that that estimate is too high, so what you do is you move it towards 1, right? To get closer, or like to reduce the difference to the red line. So that's why you shift all the betas towards the 1. And conversely here, you know that you were too low, so what you do is if you have this beta, you move it in this direction, again, to reduce the difference between the red and the gray line. It's a very hard fix, right? There's kind of no theoretical, there's a statistical view behind this, but there's no theoretical argument why this has to be 2/3, 1/3, right? You could use a half and a half if you want, right? So this is just, they settled on this, and don't ask me how they came up with the numbers. Well, it kind of, given that the security market line is too flat, you're correcting the error, right? That because your beta is, well, the expected return is not the correct one. And if you do this, you're getting closer to the actual historical estimate. So in that sense, it's like Fama and French, they observe a pattern in the data and then they just go with it, right? So in that sense, that's the same argument. But why are they using 1 here as the value that they're shrinking it towards? What happened?
Turned off.
Is it the beamer? I didn't touch anything. Okay. No idea what that was. Okay, so why did they choose the number 1 here? Why did they use 0, for example? Or 5?
It's a market beta.
Yeah, so it's the market beta, right? And that should be your average beta. So, so now if you just take a statistical approach, you don't know anything about a company, and I'd ask you, guess what the beta of the company is. What would be your best guess? You don't know anything about the company, you don't have any information.
The market beta.
Actually, you would estimate 1, right? Because on average, that's the number you should have, right? So if you want to try to minimize your estimation error, you're guessing 1. That's the reason why the 1 is there, right? Because you know that that's your unconditional average of your estimation. Everything must be on average 1, right? So in that sense, you're correcting kind of for an estimation error. That was Vazicek's original argument is, yes, you observe raw data, but that's only the beta of the last year maybe, right? So to correct your estimation error that you might make, shrink it towards the long-term average, and the long-term average should be 1, right? So there is a statistical argument behind this formula. Again, Vazicek doesn't say it has to be 2/3, 1/3, right? So the numbers are made up. They're really made up. But the reason behind it is that you first economically correct the error, that the security market line is too flat, and you're shrinking it towards the long-term average that you should expect. So there is a statistical point in minimizing estimation error. Right, so you can directly, you don't have to do this computation yourself. The modified beta will be provided by a data source like Bloomberg. You look up a beta of a company, you just directly see the modified beta of it, and then just work with the modified one. And that's what many corporations do in their cost of capital models. Right, so there are, of course, other approaches. You could have a fundamental approach on the beta, right? Think about our initial kind of way how we derived it. We were thinking about if something is pro-cyclical or counter-cyclical, right? So you can have like a logic behind it, what the beta should be, and then go with that, right? So the last year's estimate doesn't have to be kind of the correct value. It's just an estimate from the data over the last year, but there might be other factors which might lead the beta to be different in the future. So betas are not constant too, like volatilities, they're moving over time. Volatilities are moving much more strongly than betas, but still betas are not the same. And I have a paper on this, for example, that you can observe that betas in crisis, when the stock market crashes, are basically all very close to 1, because if one stock, like in the crash, everything crashes, right? So that means that the correlation between everything suddenly is close to 1, right? Because everything goes down. Right. So how would that show up in your beta computation? It would show up that all betas here go towards 1. Right? That's exactly the effect of this formula. And you can actually incorporate that into theory, and you can observe that in the data as well. Look at the cross-section of betas, they're usually very spread out, but in crisis they're all very close to each other if you measure that. So these are kind of some kind of hard fixes to kind of work with the problem, so people are not ignorant to the data. The beauty of the theory is that it's very consistent and it's logical, right? So you have kind of a very small set of assumptions that you need. Remember, portfolio theory even holds when the market is not in equilibrium, right? So it's a good sign. So you can even basically always use that. But have in mind that the capital asset pricing model might not give you like the exact data, the exact number, like 3-digit accuracy. That's not the case. It's a ballpark estimate that you should use. But don't treat it just as a black box and kind of believe everything that the model just spits out. And even if you're not continuing to work in finance or studying finance, even if you like doing marketing or whatever, you will always have some interactions with finance people, right? So it's important, like if they say the beta is 1.5, you should ask them, like, how do you get this, right? So don't kind of take everything that they just tell you for granted. Sometimes if people like have internal agendas, so maybe there is a manager who doesn't like a project, what's the best way to shoot it down if you don't have any arguments, right? You fiddle around with the numbers, right? You just present, like if you're the CFO and you want to kind of not do a project that's like the pet project of the marketing boss and you don't like him, like how do you shoot it down is you say that it's not profitable, right? So you're twisting the numbers, right? And, you might laugh about this, and of course it's a made-up example here, but in real life, there are some ways in business plans and so on where we have to do forecasting to be kind of more optimistic, to kind of let things on paper look better. So if you have a typical pattern of estimations, for example, sales estimates, there is a picture that looks like this that you can find very often. It's the so-called hockey stick, right? So at the moment, you're kind of very, like, usually it's still growing here, right? It does not have to be downwards. But you have very, very small growth at the moment, but in the future, of course, everything's going through the roof, right? That's the typical estimation picture that anyone in the real world would show you, right? And this here is, of course, very sketchy, right? That's the typical hockey stick, like it looks like that. That's what people say. Good. So be skeptical when you work with models, because you know all the assumptions now that are behind this. So, do we have any questions regarding this very long chapter, portfolio theory, capital asset pricing model, and kind of the evidence behind it? We'll come back to this again when we work through some real-world examples in our kind of data exercise classes around the break. Right? So we're going to revisit this, download some actual data from Kenneth French websites, and do some of the analysis ourselves.